Hi guys, welcome to the channel. This is Waga. We're going to do another Leetcode question, and the question in question today is number 72. Edit distance. You're given two words. You're supposed to convert word 1 into word 2, and the number of operations you can use is the number of things you can do is insert a character, delete a character, and replace a character. E.g., the word horse can be converted into the word ROS by deleting, replacing H with R, and then removing the R in horse, and then finally dropping the E so that you have ROS, right? Okay, replacing the that's how you can do it. So you replace H with R, remove the R, and then remove the E, right? So basically that is the idea. In such a situation, we could use dynamic programming to solve this problem, and that's what we're going to do. Dynamic programming is where you use a small section of the problem to solve the grander problem, right? You use a morsel of the problem to solve the mountain of the problem, to find the pattern that you will use to solve the mountain of the problem, right? So that's what we're going to do in this question. With many dynamic programming questions, we're going to use a 2D array to solve this question, right? Solve this problem. So the first thing we need to do is come here, and we could come here, write down our word, and let's make this 150, right? Because I'm going to create a 2D array, so you could just use this this word document, right? So the first word is going to be word 1 is going to be horse, and we're trying to convert it into word 2, which is going to be ROS. This is the example from here, right? This is the example from just the first example. So we're going to work it out on the Word document, and then work out how to solve it on the Word document. Then we use the logic, we implement the logic in code, right? So how we do that is we come to insert, get a table, and we're going to get a table. The length is supposed to be equal to the number of letters in one word plus 1, and the row is the same plus the middle box or thereabouts, right? So you could have 1 2 3 4 5 6 plus 1 for the horse, and then 1 2 3 plus 1, right? 7 by 5 table, right? So we have a 7 by 5 table which we're going to use to replace the number the number of operations we need to convert one thing into the next thing, right? We will basically store the minimum number of edits to do on one substring to convert it into another one, right? And we'll start off with an empty string, right? That's an empty string. We come here, we do the same. We have an empty string, and we could spell out our word. We could have horse, H-O-R-S and E, like so, and this one is going to be R-O and S, right? So the first thing we need to ask ourselves, we're going to be asking ourselves the minimum number of operations to convert one subset of a string into another one. So the first thing we do is we ask ourselves, how many operations do we need to perform on this empty string to convert it into the empty string? The answer is 0, so we can write 0 there. How many operations do we need to convert this empty string into R? We need 1. How many to convert it into arrow? We need 2. How many to convert it into ROS? We need 3, right? We do the same across, right? How many we need to convert it into H? We need 1. HO 2, and this is going to be 3, and this is going to be 4, and this is going to be 5, right? Now the next thing, how do we convert R into H, right? That's pretty straightforward. R into H, we can use, there are 3 operations, remember. There is insert, delete, and replace, right? So we can just substitute or replace, right? So we can substitute. So the number of operations is 1, right? How many to convert into R into HO? So we need 2 substitutions, right? So this could be 2. How many to convert R into HOR? Now here's the difference, right? The letters are the same, right? So all we need to do is actually to do 2 operations. We need to add H insert. What was the name? Replace. No, insert. Or is there an insert or something like that? The exact name, Insert a character. Yes, it's insert. Okay, insert. We need to insert 2. We just insert H and O, right? So because R is R, right? So the number of operations here is going to be 2, and HORSE is going to be, we need to insert the 3 letters. So in this case we have 3, and here we have 4, right? And we come to O. How do we convert RO into HO? Well, the answer is no. RO into H. We need to delete and exchange and swap or replace or whatever it was. 2, right? How many to convert RO into HO? We need 1 replacement, right? So we have 1 here. RO into HOR, we need 2 operations, 2 here, and here we need 3, and here we need 4, right? And ROS into H, ROS into H is, we need 3 operations, right? ROS into H, we need to delete 2 numbers and then swap 1, so that's 3. ROS into HO, we probably need 2, right? We need to replace 1 letter and delete 1, so this is going to be 2. And ROS into HOR, we need 2 operations. ROS, we just need to replace the R with the H and then replace the R with the S, right? No, we already have an R, right? So we need 2 operations. It's ROS into HOR, right? We have an R and an O. We need to it's actually going to be 2, right? 2 operations in this case, right? And then HORSE and HORS and ROS, we need 2 operations, right? And ROS, you need 3 operations, right? Because how would we do that? We would first 3 operations. First we have the ORS, so we could have we can't change the order, so I think there's an order thing there, right? And I think the answer is given here. How we would do that: we would replace H with R, and then we would remove the R, and then we would remove the E, so we have ROS. So there are 3 operations, so that should be the output. Now we should figure out how we came up with where is it? How did we come up with this, right? If you pick a box, can you calculate the number that is required on that box based on its position, just based on its position? So if you check, you notice that for any cell we have, the value is going to be, we're going to check if the numbers are the same. We are going to, like, if the numbers are the same, like if we pick this R and R, right? If R and R is the same, it's going to be the same as the number diagonal to it. So if we come to R and R, we find that the number here is 2 and the number here is 2, right? If we come to S and S, the number here is 2 and the number here is 2. If we come to O, we come to O and O, the number here is 1 and the number diagonal is 1. So if the numbers are the same, you look at the number diagonal to it, right? And you just put a 1 there, right? The next thing we need to check, if they're different, what do we do? Like in this case, how do we arrive at 3? What we do is we check the numbers around it to the left, diagonal and up, right? We get the minimum and we add 1, right? So if we pick this number here, 3, we check 2, 3, 4, which is the minimum? 2. 2 plus 1 for the 1 extra operation is 3, right? We come here. Here it's going to be, what's the minimum? 4, 3, 3. 3 is the minimum, therefore we add 3 plus 1, we get 4, right? Here there is no, okay, here we don't have enough information because we just filled it out. And here in the 4, we take 3 and we add 1. So basically for any box we want to look at, what we need to do is we need to look at the number to the left, diagonal and up, and we add 1. If, however, they're the same, just check the number diagonally. So basically that's how we would solve such a situation. And now what we want to do is just put all this information into code, solve it. And we could come here and say edits, and edits is just going to be x for x in range of the length of word 1 plus 1, right? Like so. And then for y in the range of the length of word 2 plus 1, like so. So to explain this quickly, what you're doing here is we're ensuring that our rows initialize with the 0 1 2 3. Basically we're doing this, right? We're making sure that our rows initialize with 0 1 2 3 until the length of the first word plus 1 to account for the empty string we added here. So it's going to be 0 1 2 3 4 5, right? So this is what this line does, right? So basically, and we add the 1 for our empty string which we added, right? And that's what the x for x does, right? For each number in the range it will add a 1, right? And then we do the same for our column, right? So for that we could just come here and say for I in range, so that you can have the column range, and this is going to start from 1 because the first one has been filled, right? And this is going to be the length of word 2, and what we want to add is plus 1, like so, right? And what we're going to do is we're just going to say edit I at position 0. Edit I at position 0 is going to be edits I minus 1 at position 0 plus 1, right? So what we have done in this situation is that we have gone down and we have set these numbers, right? 0 1 2 3, right? So we say edits I at position 0 is going to be the edits of the previous number plus 1, right? And we start off at the second one because the first one has been filled with a 0, right? So we just take this number so that you can have 0, it starts off, and then it'll be 1, and then 2, and then 3, like that, right? So we have sorted out our two the base cases for the empty string, right? So basically that. Now the next thing we need to do, let's build out the rest of our table, right? And how we would do that is we could come here and say for I in the range, and the range is going to be 1 to the length of word 2 plus 1, like so. And then we have for the j loop, for j in range, and the range is going to be 1 into the length of word 1 plus 1, like so, right? And recall the reason we're adding 1 is because we shifted everything because of adding the empty string, right? We check if word 2 is the same as if the character is the same as the character that we're checking against. Basically we're checking whether r is equal to r in this case, right? So we say if word 2 at position I, which in this case because of shifting, okay, here we're supposed to type here, I minus 1 is the same as word at position j, but because of the shifting it's j minus 1. We just look at the diagonal value, right? And we just say edits I j is going to be assigned to what was diagonally, and for that it's just going to be I minus 1 into I minus 1, and this is going to be j minus 1, like so, right? Else in this case they're not the same, right? We get the minimum of the 3, right? We just say edits of the number to the top, to the left, and to which is diagonally positioned, right? So it's edit I j, and what we want to assign here is 1 plus the 1 operation plus the minimum, and the minimum is going to be of edits I minus 1 into j minus 1, comma, and then we could just copy this to save time, right? Copy this, copy, paste, it's I minus 1, and then I I into j minus 1, right? And then after that it's going to be I minus 1 into j, right? So we get the minimum of the value to the left, the top, and diagonal, right? So we get the minimum, and then we add 1 to it, and we assign it as a edit I minus j. So another thing you could do is we could make a correction here. This is supposed to be word 1, and we're supposed to set that. We're supposed to check the equality there, not assign, right? So after all this is done, what we need to do is just return, and what we want to return is going to be edits, and what we want to return is going to be the very last element of our 2D array, like so. And if we run our code, it's accepted, and if we submit it, it's accepted. Now the space complexity is going to be O of n by m, where n is the value of word 1 and m is the value of word 2, because we create a 2D array with their lengths, right? And then we add 1, of course, we can ignore the 1. And the time complexity is going to be the same, O of nm, right? It's going to be the same. It's going to be O of nm for our, I was just checking my submission. It's going to be O of nm for our time, because we have to go through both arrays, right? So basically that, right? And remember, it's not O of n squared, it's n and m, because as you saw, horse and Ross have different lengths to them. So basically that is. We could, however, use memoization to make it more efficient, to make the answer more efficient, right? To make the space complexity rather more efficient. But I won't have a look at that. I think this this method is suitable, and it's the one that I understand the most, right? I understand this straight out, because if you draw it out on the 2D array, this one makes a lot more sense, right? So thank you for watching. Subscribe to the channel, and I'll see you in the next video.